Reminder, here are the steps we've been using when we use triangles to solve problems. And here are the double angle identities that we're going to use in this video. Today we are going to work through problems like this, where we don't have numbers necessarily, we have letters mixed in. Okay, so this looks a little funky because it's not straight up like the past few examples we've done, but reminder, when you see this notation, you can rewrite this as tan theta equals v. So they're giving me the TOA fraction, and they're asking me to find sine 2 theta when the TOA fraction is v, or v over 1, because we can write anything as a fraction if we put it over 1. All right, so I'm going to draw a triangle to figure out what my sides are for the theta angle. And then I'm going to use this identity here and sub in my SO and CA values to figure out what sine 2 theta is. So let's do that. You can draw your triangle and orient it however you want to. Label the sides of your triangle. You should be able to do this by now. We've done it 1,000,001 times. This is the TOA fraction. And find your third side using Pythagorean theorem. All right, this is weird, but our answer for the hypotenuse is this expression here. We're going to have a square root. We're going to have a plus sign in there. That's as much as we can do to simplify it, and that's okay. It's okay to have something funky like that. All right, now that I have my whole triangle set up, I am going to write out the sine 2 theta identity. Replace each of these with their SO and CA fractions. So I have my 2, the SO fraction opposite over hypotenuse, the CA fraction adjacent over hypotenuse, and if you need to write 2 over 1, just to make it clear all three of our fractions here, do that. All right, let's multiply this all together. So multiply across the top. 2 times v times 1 is 2v. Multiply across the bottom. 1 times this square root times the square root again. When you multiply a square root by itself, it cancels out the square root symbol. And we don't have to do anything else from here. That's it. We're done. So it started off a little intimidating, and it was kind of weird to have a square root in there as our hypotenuse. But it's not any different than what we've been doing. Just take it a little step at a time. Draw your triangle, figure out your third side, write out your identity, replace sine and cosine with their SO and CA fractions, and simplify. Let's do 2 more examples though, just to make sure you've got this down. All right, this is the same thing as asking me what is cosine 2 theta if the cosine fraction is 4v, or cosine theta is 4v, over 1. I went on and turned it into a fraction by putting it over 1. All right, I'm going to draw my triangle. All right, find that third side using Pythagorean theorem. Distribute your squared to both the 4 and the v. We can't combine like terms here because one has a v with it and one is just a number. And do not distribute your square root to the 1 and the 16v. That minus sign holds them together as one entity, so you can't distribute. You can only distribute a square root if you're multiplying only or dividing only. Because of that minus sign, we're going to just leave this as that long expression there. All right, now that I know my triangle, write out the cosine 2 theta identity. You have 3 choices here, and it doesn't matter which one you use. I generally use this one, although technically we could have used this from the beginning and just straight up substituted that in here and square it. And that would have been a lot easier. I should have done that, but whatever. I'm going to continue doing what I'm doing just to see that we're going to end up with the same answer. So actually, that's my answer here. Let's do that here. All right, the ka fraction is just 4v over 1. The so fraction is that weird square root. All right, when you square this, you have to square both the 4 and the v. When you square a square root, it cancels out the square root symbol, but I am subtracting here. And when you subtract, you need to make sure you distribute that minus sign to both parts. And now combine like terms. I have a 16v squared and a 16v squared. I have two terms that have a v squared with them, so I can add them together to get 36v squared. And then I still have that minus 1. So notice this is the same answer we got when I used that other identity. You just pick which identity you want to use, and you'll get the same answer either way. All right, let's do one last example back to sine 2 theta. So I am looking for sine 2 theta, and they tell me that the cosine theta fraction is w over 1. Draw your triangle, label the sides. This is the ka fraction. Now that I've got my triangle set up, I need to write out the sine 2 theta identity. Replace sine theta, the whole sine theta, with the so fraction, which is that square root over 1. Over 1 we don't really have to write. And replace the cosine theta with the ka fraction, which is just w over 1. Over 1, again, we don't have to write. And then multiply it all together. So the 2 and the w stay outside of your square root, and this is obviously going to stay underneath my square root. Generally, we write the square root last. You don't have to, technically. Just make sure it's clear what letters and numbers are under your square root and what letters and numbers are not. But that is my answer.